Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Storage can be grouped into three main categories: local storage, network-attached storage, and cloud-based storage. Each of these options has different strengths and weaknesses in terms of access speed, availability, cost, and security. In the CompTIA Tech Plus exam FC0-U71, you will be expected to compare these types and apply them to specific use cases. In this episode, you will learn when and why each type is used, so you can match storage solutions to the right environment. Local storage refers to devices that are physically connected to a single computer. This can include internal hard disk drives, internal solid-state drives, USB flash drives, and SD cards. With local storage, data access is fast and does not require network connectivity. The stored data is tied to the device unless it is copied or synced manually to another location. Local storage is typically used for personal files, operating systems, and offline access to applications or media. Common forms of local storage include internal solid-state drives, which provide high-speed boot times and quick application loading. USB flash drives are portable, rewritable storage devices ideal for transporting small to medium files between systems. External hard disk drives and external solid-state drives are used to expand storage space and for performing backups. SD cards are removable memory cards often used in cameras, tablets, and embedded devices such as single-board computers. Local storage offers several advantages. It provides immediate access with low latency and high transfer speeds. Data stays entirely on the device, with no reliance on internet connectivity or third-party servers. There are no ongoing subscription costs like those found in cloud storage models. Users have complete control over access, security, and how long the data is retained. However, local storage also has limitations. It has limited scalability, meaning capacity can only be increased by replacing or adding physical devices. There is a greater risk of data loss due to damage, theft, or hardware failure. Access from multiple devices is not possible unless files are manually transferred or synced. Backup and redundancy require the user to take responsibility and maintain separate backup media. Network-attached storage, abbreviated as NAS, connects to a local area network, or LAN, and provides centralized storage accessible to multiple devices. An NAS system acts as a shared file server for a household, a small business, or a media center. Users access files through network protocols such as SMB, NFS, or FTP. This makes NAS a common choice in collaborative work environments or for storing shared resources such as media libraries. Key features of NAS devices include the use of multiple hard disk drives in a RAID configuration for redundancy and performance. They can be accessed by hostname or IP address from any device on the same network. Many models allow user account creation with permissions, offer built-in encryption, and support remote access. Some advanced units can run applications, synchronize with cloud storage, or serve as surveillance camera storage. The advantages of network-attached storage include enabling file sharing, backups, and collaboration without relying on public cloud services. Centralizing storage allows multiple systems or users to access the same files easily. With RAID configurations, a single drive failure will not result in data loss. Many NAS units can be expanded by adding larger drives or additional bays to meet growing storage needs. Limitations of NAS storage include the need for some technical knowledge to set up and configure the device. Performance is dependent on network speed and the hardware inside the NAS unit. Compared to a simple external drive, the initial cost of a NAS system is higher. If the local network goes down or is misconfigured, all users lose access until it is fixed. Cloud storage hosts data on remote servers operated by a third-party provider and is accessed over the Internet. Examples include Google Drive, Dropbox, Microsoft OneDrive, and Apple iCloud. Files stored in the cloud can sync across devices and be accessed globally as long as you have internet connectivity and proper login credentials. Cloud providers manage the infrastructure, software, and maintenance, typically billing customers through a subscription model. Benefits of cloud storage include anytime, anywhere, access to files across multiple devices and operating systems. Many services offer automatic backups, file versioning, and real-time collaboration tools. Using cloud storage can reduce the need for large local drives and simplify sharing files between users. Cloud storage can scale easily using pay-as-you-go models, so you only pay for the capacity you need. Drawbacks of cloud storage include the requirement for a reliable internet connection to access your files. Subscription costs can add up over time, especially for larger storage plans. Data privacy and control depend on the policies and practices of the provider. If the provider suffers a security breach or an outage, your data availability may be affected. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Comparing local storage, network-attached storage, and cloud storage starts with understanding the key trade-offs. Local storage provides the highest level of control and the fastest speeds because it operates directly on the device without network delays. However, it lacks scalability and does not allow easy access from multiple devices without manual synchronization. Network-attached storage allows multiple users or devices on a local area network to share and back up files without depending on internet access, but it requires functioning network infrastructure. Cloud storage offers global access and automated synchronization but introduces reliance on a third-party provider for uptime, data security, and privacy. Each approach has environments and use cases where it is the best choice. Hybrid storage approaches combine two or more of these options to achieve flexibility and redundancy. For example, a laptop might have an internal solid-state drive for local performance. Synchronize important files to a network-attached storage device for shared access, and back up essential data to a cloud service for off-site protection. This kind of hybrid model balances cost, speed, resilience, and accessibility. Technicians and system planners must understand how to integrate these storage types effectively, ensuring they work together rather than creating conflicts or redundancies. It is also important to distinguish between a file server and a network-attached storage appliance. A file server is a full computer system running an operating system configured to provide network file storage, which can include advanced permissions, domain integration, and application hosting. Network-attached storage is a dedicated appliance designed specifically for storage and file access, with a simplified operating system optimized for this purpose. File servers tend to be more flexible and scalable but require more resources and maintenance. NAS systems are simpler, often more energy efficient, and better suited for small to medium deployments. Cloud integration with local systems is a common practice. Many cloud services, such as Google Drive and Microsoft OneDrive, install client software that synchronizes files between local folders and cloud accounts. This ensures that changes made on one device are reflected across all linked devices without user intervention. These synchronization clients can be configured to control how much bandwidth they use, whether files are stored locally for offline access, and which folders are included in the sync. Remote access is another area where storage types differ. Network-attached storage devices can be configured for remote access using methods such as Dynamic Domain Name Service, abbreviated as DDNS, or through a virtual private network, abbreviated as vPages-N. Cloud storage is inherently designed for remote access and collaboration, as long as you have internet connectivity and valid credentials. Security features such as permissions management, encryption, and multi-factor authentication help ensure that remote connections remain secure. Planning storage capacity is critical in both home and business environments. The amount of space required will depend on the type of files being stored and how long they must be retained. Local storage is constrained by the physical capacity of the installed drives, Network-attached storage can often be expanded by adding or upgrading drives, while cloud storage can be increased almost instantly through subscription upgrades. Archiving older or rarely accessed data to network or cloud storage can help free up faster, local storage for active use. Backup strategies vary by storage type. Local backups are quick to perform but are vulnerable to the same physical risks as the primary storage device. Cloud backups provide off-site redundancy and can be scheduled to occur automatically, protecting against physical disasters or theft. Network-attached storage can act as a local backup target, and in some cases synchronize with a cloud service for a multi-layered approach. A common best practice is the 3-2-1 backup rule. Keep 3 copies of your data on 2 different types of media, with 1 copy stored off-site. Different environments call for different storage choices. Local storage is ideal for personal workstations, secure standalone systems, or environments where internet access is unreliable. Network-attached storage is popular in small businesses for centralized file sharing, media serving, and collaborative document management. Cloud storage is valuable for mobile workforces, remote collaboration, and environments where rapid scalability is needed. Selecting the right storage type requires considering the number of users, the sensitivity of the data, and the available network and internet resources. Common troubleshooting scenarios also vary by storage type. For local storage, you might encounter issues such as the drive not being detected, insufficient space, or file corruption. For network-attached storage, problems could include access permission errors, network misconfiguration, or RAID failures. For cloud storage, issues may involve synchronization conflicts, incorrect permissions, or restoring previous file versions. Knowing the typical problems associated with each storage type helps you isolate the cause and apply the correct fix quickly. On the CompTIA Tech Plus exam, you may be asked to match a storage type to a specific use case, troubleshoot a connection problem, or identify features of flash drives, NAS devices, or cloud storage services. You should be able to weigh pros and cons in terms of speed, cost, availability, and security, and clearly differentiate between local, remote, and network-based solutions. Some glossary terms to review from this topic include NAS, LAN, SMB, FTP, sync, RAID, cloud storage, local storage, external drive, and hybrid storage. Revisit earlier glossary-focused episodes to strengthen your recall of these terms and to see them used in technical contexts. Flashcard drills or matching exercises can reinforce distinctions between interface types, storage locations, and connectivity options. In real-world IT roles, understanding local, network, and cloud storage is essential. IT professionals regularly assist users in choosing, configuring, and maintaining storage solutions. Small businesses often use a hybrid approach, combining a NAS device for daily operations with cloud storage for redundancy. Technicians need to know how to mount drives, map network paths, configure synchronization tools, and secure storage at every level. This knowledge directly enhances your value in support, infrastructure, and system administration positions. In the next episode, we will move to the installation and configuration of peripheral devices. This will include printers, displays, keyboards, webcams, and other accessories. You will learn how to identify plug-and-play devices, handle manual driver installations, and set up Internet Protocol-based configurations. These skills will support both the infrastructure domain of the exam and practical, real-world tech support work. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.